Hey folks, this is section 3.8 and I'd like to do an example for you. So in your notes, go down to section 3.8, number 38, and the directions here say that we should graph by hand and solve. Notice that I've been given a polynomial, p of x, and they were nice to us. They actually went ahead and did the factoring for us on this one. So we understand from section 3.6 and 3.7 that solving is very simple on this one. Part A, solving p of x equals 0. This is very simple because all we have to look at is our three factors and turn them into zeros, because remember the word solve is the same thing as go find zeros. So this part is going to be really simplistic. We know that we have our first solution is x equals 3. Our second solution is x equals -2, and our third solution is x equals -5. I can go ahead and put these on my graph as well, since the ultimate goal here is to graph by hand. So I'll just put here 3. There's one of my zeros. -2 and -5. Now, before I move any further with this, let's look at some of the things that I know. One of the questions that I would ask myself is, what's the end behavior? And remember that we look at the degree for this and we look at the leading coefficient. So the end behavior starts at the bottom. It works its way to the top. It's a 1 up, 1 down. So on my graph, I know I'm starting down at the bottom and I'm ending up at the top right. The second thing that you might want to consider for graphing by hand is where the y-intercept is. Remember, y-intercept is found when you plug in 0 for x and then you solve. So if I plug in 0 for all of my x's and solve, I'm going to get a y-intercept at the coordinate 0, -30. The third thing that you want to consider is your zeros. What is the multiplicity of each zero, and are they bouncers or are they breakers? So since each zero only occurs one time, the multiplicity of all three of my zeros is 1. So that means that all three of my zeros end up being breakers. So all zeros break through. This is enough to go ahead then and graph. I'm not real worried right now about how far up and how far down your graph goes. So this may look like your graph, and you say, well, what about that y-intercept at -30? Wherever my graph went through the y-axis, I'm going to call that -30. So that takes care of that. Now part B is asking us, where is p of x less than 0? Okay, so let's look at this. Part A is, where is p of x equal to 0? We know that equal to 0 is on the x-axis. So we're going to visit Sesame Street here. We have on the x-axis. Greater than 0, we know is, that says less than 0, is less than the x-axis or below the x-axis. And then greater than 0, these are positive numbers. This is going to be above the x-axis. So let's look at part B first, and you ask yourself, what pieces of my graph are below the x-axis? Well, all of this down here is below the x-axis, and this valley right here is also below the x-axis. Now there's an infinite number of values below the x-axis, so the only way I can answer this is through intervals. Remember, intervals are only going to use your x values. So my intervals, all of the numbers, all of the x values that are below the x-axis, it's going to begin at -infinity. Why? Because those are the numbers to the left, not down, to the left. -infinity all the way up to -5. I used a round parentheses there because I don't want what's on the x-axis. I only want what's below the x-axis. And then the next piece of numbers that's going to be below is going to be from -2 all the way to +3. These are the numbers that are going to be below the x-axis. Now part C asks me what is above the x-axis. So we've got this piece here, and we have this piece over here. And once again, that's an infinite number of values, so we'll have to use intervals for this. So from -5 to -2, all of those values are above the x-axis. And the second piece of that is going to be from 3 to +infinity. Why +infinity? Because it's going to the right.